Hello there. Welcome to the archive. Hmm. Check the audio. Yeah. So, there is a issue with jukebox. Um, let's just get into it. I'll show you. This is the repository for jukebox. Uh, we can search here. Now, the sample rate I thought was a variable is only mentioned wherever it's mentioned, uh, it's it's I've been following where HPS is the hyperparameters, SR is the sample rate. It lives in the hyperparameters. Now I thought that that was somehow used during training. It was not. So the network, I think this file is a good one. The network is, I believe, but I'm not sure, but I think that it's trained on one single sample rate, probably 44-100. Although uh, it does have here when it's tested, it's set to 22050, and it's also referencing other sample rates here, 22K, 44K, 48K. But if we go to the train file, train.py, this is what they supposedly use to train the network. Let's go down to the bottom. Fire.run run, or fire.fire run, which is this method. HPs equals teeny. Important. HPs equals setup hyperparameters HPs. So we're giving it a string and then we're overwriting that name with our actual hyperparameters. So let's go to that definition right here. And as you see, HP params set names is, well, split, but then it's used to get things from HP params registry. And well, there's teeny. It's completely empty. Then you have easy, 22050, okay. Then you have some other things. However, what I found, like, yeah, none of these, there are a bunch of these. None of them specify sample rate, except this one, the easy one. The teeny one specifies absolutely nothing. So let's go back up to that method again. And we continue, and then we also see that, oh, it's also gonna, before it actually uses this further down here, It's actually gonna grab stuff from default over here. Everything from all defaults. So it's gonna add all of this. All this, all this, all that, all this. All this is default. And then you go down to the bottom and you found the audio default section. And the sample rate is at 244/100. This to me indicates that the network that is supplied on the CDN is trained on 44/100 hertz. Well, 4400 kilohertz, yes. No, 4400. 4400 hertz, yes, brain fart. Channels 2 for some reason. I never noticed that before. Hold on. Where is channels used in here? I guess it's HPs.channels. Now that is set to 1 on the models we were supplied, because we only have one channel generation. This might be for this might just be for data loading though. No, it is actually going to pass it. It actually does expect channels, amount of channels. Interesting. So, let's find the actual configuration, I guess, then. What the heck? So, channels by default is 2, but on the models we have it's 1, so it's not teeny. So, let's check which one it is then. What? Okay, so the configuration they used is not in here. I mean, that is sort of kind of half expected, given that there is some code missing from somewhere. I don't remember. It's I think it's the lyrics or the labels conditioner thing. That's just replaced with a comment like, oh, put your own code here. So it's kind of expected that the configuration they used is not even in here, which is that channels equals 2 pretty much tells me. So it's all kind of unknown, I guess. But the thing is, then again, the default or the original interacting with jukebox here does set it to 44/100, and this was made by them. So I guess that's what they trained it on. Hmm. Yeah, but so yeah, let's fix that then, I guess. That's the problem, that's what needs fixing, let's fix it. And the first thing to do is to go down here to hps.sr and stamp that out and replace it with a static number. Oh boy, this just broke everything. My code is currently broken. I should put that at the top here. Code is broke under construction. If anyone for some reason opens the links to this notebook right now, this can go. Yoink. This is now false and can now technically be any number, so that's a win, I guess. Yeah, let's go through this and see what must change. These notebooks, I'm pretty sure they run, yeah, they must be running Python 3 since Python 2 is technically no longer supported. So I don't really need to worry about float division crap. Yeah, nice. Remember in Python 2.7 that if you divided two integers, you'd get an integer? Even though if you divided any other float with any kind of other integer, you'd always get a float? Python 2, yay! I think that was Python 2. I might be mistaken. Anyway, all this can stay. All this can stay. That can stay. Now begins the real differences. We will not even touch the sample rate. The sample length is gonna stay that way. Samples per beat is gonna turn into a float. That's most definitely not an integer. Here's the thing. I'm gonna have to break this up into tokens eventually. One token is 128 samples, so there's gonna be some jank there. We'll figure it out through basic logic and intuition and math. We will be fine. But yeah, samples per beat, I think that can stay the same. Seconds. Whack. Yeah, this is whack. Why did I never change this? First of all, is this used anywhere? No, it's not. Good. So yeah, let's just remove the sample rate entirely out of this equation and just do a So, actually, so. Yoink. Probably want to turn that into a float anyway. Or do I? What the hell am I even talking about? We have 64-bit floats. Precision is not a problem. LOL. Seconds to token. I guess that was up here. Yeah. You know what? Why is that even a freaking function? Is that used anywhere? It's literally where it... Get out of here! Well, there you go. Seconds times sample rates. Integer division by prior. Yeah. Perfect. That's gonna... Ooh. Yeah. Not integer division, because we want to keep it afloat. I think that's gonna work. Let's continue. Oh yeah. Look at this. Kind of want to move this over into this section because it kind of belongs there. TBH. Like if you run this, you're always gonna have to run this anyway, so don't mind me, I'm just doing house cleaning, I guess. Speaking of house cleaning, oh yeah, wait, chunk size. Did I keep that there, or did I remove that? Where is it? I'm blind. There. Yeah, I removed it. Okay. Go there. Nuke that. Not gonna need that. And I honestly want to make this proper. Python if exist. Is that a thing? In locals, okay. Actually, I'm just gonna do it simple. Oops. So this is gonna conditionally create it first time. And if we rerun this part, it's not gonna reload the priors or VQVE unless the level has changed. I believe that's the only uh, like dependency for them. Yes. So yeah, that goes beep. And then we define some helpers. We get our start. All that's still the same. Uh, we set up power monitoring. Set up file decoding, and then we actually get into the meat of things. Why is this scrolled? Yeah. Set up some stuff. The lighting is not gonna work anymore. I have a fix for that anyway. I can still be that way. Yeah, we're gonna put that back in because it's actually kind of working properly. Or we will need it to work properly. Ooh, but it might be might be uneven. Well, then we do have the fallback. I will see. God damn it! This is. This is junk. This is debatable. Now, for the main actual fix that we need to do. Oh yeah, we can't do that anymore. RIP. I'm gonna have to replace gen token there with something. Tokens left. Tokens left equals something. Actually, minimum tokens left or it's where is it? Hop fraction, yeah. What? Am I typing correctly? Where am I typing? Hello? Okay. Is it fractions or fraction? Fraction. Singular. Current sampling level of that. And we're gonna have to get an integer at the end. And we're gonna multiply that with the context length of the prior. Prior. Prior.n underscore ctx, I think it is. I believe I use it up here. Yeah, nctx. And it's top prior, not just prior. So either the maximum amount or what we have left. And while tokens left, I believe. And at the end, subtracts this amount again. I'm gonna you see that it's the max tokens, I guess. It's gonna be int. Well, that's above 0. Yeah. So, still need to figure out how many tokens. We did have tokens to sample. This is tokens per beat. Is this referenced anywhere else? No. Now tokens per beat is gonna be a float, most definitely. Let me just run through this. What did I type? Oh, there. Let's just run through it. 60 over, let's say, 105, sure. Seconds per beat, 0.5, sure. Times 44,100 divided by, let's see, we're on the lowest layers, so 128. 196.875. Well, it's a rational fraction. Well, of course it's a rational fraction. I guess what I mean is, at least it doesn't run into the precision wall of floating point numbers, which means it won't drift. Okay. I guess that's the new qualification for if it will drift or not. Like, do you run up into the floating point precision wall or not? Yeah. So that is a float, and I will take out the multiplying that with the prime and gen tokens, because I kind of want to keep those as integers, just as straight beat indicators. So now what this loop here has essentially no idea where it is, how it like where it is in the context, or like where it is in the song along the length of it. So we're gonna have to extract that, truncate it to the nearest beat, and then add a beat to it, and then compare that to where it currently is, to do it properly. To do it naively would just be to add a fixed amount, like we've been doing, but that requires that the sample rate changes to accommodate the drifting. But now when I'm taking that out, I need to do this. I guess we can use the round function. Yeah. Or, if we want to be really explicit about it, we can just do a truncation plus 0.5. That's basically the same as rounding. It is the same as rounding. But yeah, we need to get our current position. Yeah, we're gonna get level complete. We're gonna divide that by tokens per beat. That's gonna be a float. But now we're rounding it both up and down in case it jitters around, and it will do that because well, there's a decimal, it's gonna by definition jump around at least a sample. What next? That's one set of... That's our current position. Add one. No, add gen tokens. Because that's beats. I guess I should rename gen tokens and gen beat and gen and prime tokens to gen and prime beats. I will do that. Yeah, there we go. This comment cannot go because it's outdated. That's how quick a comment gets outdated. I literally commented that out a maximum of 30 minutes, 40 minutes ago. At a maximum. And it was already outdated. Comments, man. Back to where we were. Oh, it is used. Oh, there too. Shit. Shit. A lot of code is broken. Yeah, a lot of code is broken to hell. I mean, I could have them as tokens. However, I kind of want the precision. This line here at the top is still correct. It's still, this is still working. Or no, it's not. Whack. So I guess I just multiply in the beat tokens per beat. Okay. If you say so. just multiply it in there. Int. Ooh. That's not a multiple of 128. Oh Jesus. Yeah, this is where the jank comes in. We need to align to 128 bytes samples. Balls. Actually, it will if I do if I do this. Man, that's jank. It works. I think. Yeah, this is not optimal. There's some slippage here depending on the beat you select, but it self-corrects. It shouldn't be a problem. Or not depending on what beat is, but the amount of beats will slightly affect the alignment. But it's only on that beat and it's gonna jitter anyway. But the goal is to basically realign every time with this thing here. So yeah, all this needs to be yanked out and replaced. Yeah, let's leave that for a while. So we get the amount of tokens we have, then divide that by tokens per beat, which basically tells us how many beats are we currently at, and then we round that, and we add our actual section we want to do, and now we multiply it up with the tokens per beat again, I think. And this is what's, because I'm dividing it by tokens per beat and then and doing all this and then multiplying it up again, I'm making sure that I stay on alignment. It kind of like, it snaps to alignment every cycle. So that's a mess. It should work. Now, to fix Z's, or, well, the encode. I guess all this again, in a way. So after we generate, we then again get our current level, which now has this amount on it, plus or minus epsilon, I guess. And then we again truncate it, or we, not truncate it, we We round it to get our alignment back. Then we add the beats and then we multiply it out with the float to get approximately where we should go to next. And then we make an int out of that. Yeah. So yoink. No, it's 2 there. Yeah, from where we have ish. Oh, I didn't think of this. It's gonna be clicking. I need to solve this. How do I solve this? I'll just do this. Current tokens, next tokens. Sure. Now notice that current tokens may or may not be exactly the same as get level complete, even though that's sort of what it's kind of is. Whack, right? This may introduce very much wackiness. Sure, I'll introduce that too. Ye. So that's our selection of the original. Now we're gonna have to cut it. I'm gonna call this cut tokens. Wow. Notice how I'm always going down to the integer and then adding this and then multiplying up. That's to keep the alignment. Now cut tokens should be there. That should work. Man, that's jank. And I'm gonna put in a shorthand here called foo. And what is foo gonna be? Foo is gonna be this part. Because frankly this is too wordy. What the heck? Why are things going kinda wacko? Like what the... What the... My god. My eyes are not working. Oh yeah, that makes sense, because it's... Yeah, that makes complete sense. Yeah. Yeah, there we go. I was like, what the hell? These parentheses are not adding up. But now they are. But yeah. Also, we might as well, for the helmet, add 512. Add 512 for margin. For VQVAE. I noticed that I haven't exactly read into the code, but there is some kind of adjacent looking for VQA, so I want to make sure that I include enough information from the future to have it do a proper token, so that the network can later infer what VQA or what it kind of wants happening next. It's weird, but yeah. I think that is it. Hmm. Yeah, that's it. I might store a little uh, uh, storage dictionary here. So you can like see how many of each, like what your distribution of tokens are. Token history equals that. It's gonna be very simple. Where is it? Where is it? Where is it? I basically want I basically want if tokens left, if not tokens left in token history, then token history of that index, tokens left equal 1. Else plus equals 1. So that's token history for generated tokens, not for cut tokens. I guess I can print it either way. Print tokens left. And so this is done. Print token history. Save. Oh yeah, this is broken to hell now. Whoops. Actually, none of these two lines don't make sense at all anymore. This doesn't make sense at all anymore. Can I comment things out in a multi-line string? No, I can't. Can I be like lol 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 lol? No, I can't. Yeah, there we go. Ow. I think that should work. I think that should work. Let's test it, I guess. Yeah, let's. I do know I have. A file here. Let me just archive this. Yes. Yes, Google Drive, please. Okay. Where did I put... Is this it? Is this the... Where's the primer audio? It should be here. Is it this folder just named as dasd? Can't preview file. Bullshit. F5. Play anyway. Ow. Sure, that's good enough. I believe yes. This has already... wait, I need to move it. Yes, move. Thank you, Drive. Okay. Welcome back to the main screen. I have here a primer. And I will rediscover what BPM I synced it to, because it's not... I don't remember, simply. So let's load it in. Ow. 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 What the hell? There it is. So, let's ask the computer what did I have figured out. What do you think, PC? You think... What the hell? No. Or is it? 122.75 122.752 times 120. Why am I multiplying by 128? Why do I insist of getting... Here's the thing, it's still in sync. Good music though. So, why did I get this one when I can just get the original one? Yes, let's do that. Yes, let's do that. Where is the original one? I think I have it in here. It should be in here. It is. Whack. You probably can't hear, can you? No, you can't. You probably don't want to hear. Negative 12 decibels. I think that's good enough. Can you hear me even? Yes, you can. Beep. Beep boop. Bop. So yes, we're gonna do one more time by the now late Daft Punk band that's disbanded not too long ago. Eight, 7, 8. Can't have enough cowbell. I mean, I think that's pretty good. I don't think I need to do anything. I mean, precision is kind of thrown out the window anyway because we're working with floats. But I think that's good enough at the end of the song. It's pretty much in sync. So to be fair, I did cut it at the beginning, so I do need to export it again. Export as primer. Yes, overwrite. Thank you. Hey primer, you're dead. There it is. Let's upload that. Let's set up our thing for Daft Punkness. Something I learned, or something I'm trying to investigate, is upsampling temperature instead of just sampling temperature. It seems like having it lower than 0.99 might actually remove some demonic noise or something. I don't know, it seems investigations are needed to see how viable it is. Let's see how long we should go for. 520, I guess. Artist condition, Daft Punk. Is there a Wikipedia article on this song? French House. Okay. Let's pop in the lyrics for one more time. Sure. Nope. Come on. Thank you. That's a lot of words. Should I keep the brackets? Does jukebox generalize to understanding what the words inside brackets actually mean? Maybe a little bit. I have a feeling it's just not gonna say what's inside of it. Just be silent during it. I don't know. I don't know. I mean, I have no idea how the lyrics for the actual model was post-processed, so frankly, I can't format it properly, basically. Or well, I don't know how, or if there's a proper format for the lyrics. Like, what did OpenAI decide? So yeah, I fixed the div thing, I believe, because I replaced it with the tokens left here. So, and div is entirely gone, which means it can go yeet itself. Yeet, yeet, yeet. Um, it needs to know how many tokens to. It needs to know a proper chunk size. Oh boy. Oh boy. I mean, we could just do this to start with. Oh. Yeah, that hurts. Okay, I kind of lost my train of thought there. I was thinking of the tokens of the chunk size, yes. And yeah, let's just try it. That worked. Wow. Yeah, we're not going to need anything in there. Okay. Man, this is turning into spaghetti code. I should really clean this up. Yeah. Run all. Oh yeah. Beep, 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 beep. This is gonna take a while, so yeah, I'm gonna stop the stream here. Go do something else. I'll monitor this. Let's see if we get any errors before we start loading the priors. Oh, we're loading VQAE. Oh, that's a good sign. Oh, wait. Did I fix this? Yes, I did. Nope, I did not. This is... Oh, I forgot this. This is not gonna cut properly now. Now it's gonna cut properly, but... I need to make it error. I think I'm hearing a snowplow. What the hell's a snowplow doing out at 4:27 a.m.? Either way, hey you, die. Hey Python, what's a decimal hard divided by... It's still okay. It's still a float, but it's oh my god, that's bruh, a float, but you, man, that's some janky shit right there. Liberal use of the int keyword right now. And we are gonna restart and run all, yes. So technically it would have errored. Yes, Google, I am not a robot. I just I just use Colab too much. Sorry. Loading prior. Rip RAM. Yeah. That, I mean, in my head it runs. And as soon as I said it fucking crashes. Why did you crash? Uh, uh, okay, I guess that was because I interrupted the... That was because I interrupted it on the download. Factory reset, yes. Control S. Control S. Just to be sure. Run all. Ay. What is file validation? I have no idea. Well, I guess I'm gonna log in here yet again. But I think I'll be going actually. Do something else. I think there's not gonna be much more issue after this. Should be completely fine. I believe. But then again, I'm often wrong. Yeah. Yeah. Should be fine. Should. Keyword should. You just don't know, but yeah. I'm gonna go do something. I'll be back in 5 minutes, see if it's crash or not. And we may see a new and improved version soon that is actually not gibberish. Like, I never kind of explained what the issue with the previous version was, but again, not sure. But since I believe OpenAI trained the model at 44.1 kilohertz, that's what it thinks is normal. And if I present it tokens that are made from a 8 kilohertz signal, it's gonna be like, dude, this sounds pitched up way to hell. I'm gonna pitch that down just a little bit. And that's why everything gets pitched down with the old notebook, because usually the sample rate was below 4400. So yeah, that's kind of what like tipped me off to all of this. Like, most voices that, or most artists and voices that are in jukebox that I told it to do, it usually dipped their voices down. I was like, maybe that is the sample rate. And as it turns out, it basically is. Sample rate is not accounted for at all. And the only way I believe you could account for wacky sample rates is to feed that to the network as well, and also variate it during training. But none of those two things are being done. So I can only assume that the network was trained on statically on 44.1 kilohertz. And that's why it keeps acting weird on some songs, because the pitch shift is different for each song I do, because it's different per BPM. And most songs have a different BPM. But yeah, we're downloading the prior. yeah, I won't bore you. This is now a waiting game for me, so I'll see you some other time. Goodbye.